Graphs are beautiful. But let's be honest, plotting points by hand is slow. And if the answer is something like 49 over 29, good luck reading that off a graph. So now we go algebraic, two methods that crack any pair with pure arithmetic. Substitution and elimination. By the end, you'll know both cold and know which one to reach for. Let's go. Two methods, same goal. Find the x and y that satisfy both equations, no graph paper needed. First, substitution. Rearrange one equation and plug it into the other. Then, elimination. Combine the equations to cancel a variable. We'll do each step by step with the special cases that tell you when there's no solution or infinitely many, slow and clear. Substitution. The idea in one line, get one variable alone from one equation, then plug that into the other. That turns two equations in two unknowns into one equation in one unknown, which you can just solve. Let's do it. Equation 1, x plus y equals 14. Equation 2, x minus y equals 4. Step 1, get one variable alone. From equation 2, x equals 4 plus ey. Step 2, substitute that into equation 1, 4 plus y equals 14. That's one equation, one unknown. Simplify. 4 plus 2y equals 14, so 2y equals 10, so y equals 5. Step 3, back substitute, x equals 4 plus 5, which is 9. So the solution is x equals 9, y equals 5. Done. And you can check that both equations hold. Two things can surprise you. If, after substituting, every variable cancels and you're left with a true statement, like 18 equals 18, that means the two equations are really the same line, infinitely many solutions. But if you're left with a false statement, like minus 4 equals 0, the lines never meet. No solution. A true leftover means infinite. A false leftover means none. Okay, quick problem to test yourself. It's on screen. You'll get 10 seconds. Pause if you need longer. When the variables vanish and you're left with a true statement like 7 equals 7, the two equations are the same line, so there are infinitely many solutions. That's option C. A true leftover always means infinite. Now, elimination, often even faster. The idea, make the coefficients of one variable match, then add or subtract the equations so that variable cancels out entirely. Example, equation 1, x plus 2y equals 8. Equation 2, 3x plus 4y equals 20. Step 1. Make the x coefficients match. Multiply equation 1 by 3. That gives 3x plus 6y equals 24. Step 2. Subtract equation 2 from it. 3x minus 3x is nothing. 6y minus 4y is 2y. And 24 minus 20 is 4. So 2y equals 4. Step 3. Solve y equals 2. Step 4. Back substitute into equation 1, x plus 4 equals 8, so x equals 4. So the solution is x equals 4, y equals 2. The same two surprises apply. If both variables cancel and you get a true statement, it's infinitely many solutions. A false statement means no solution. Exactly like before. And which method should you pick? If a variable already has a coefficient of 1, substitution is usually cleanest. If the coefficients line up nicely for canceling, elimination is faster. But here's the comfort. Both methods always work, and both give the same answer. Your challenge, it's on screen. Pause, work it out, and drop your answer in the comments. I read every single one. And that's the whole chapter. You can form a pair from a story, solve it 3 ways: graph, substitution, elimination. Name every case, and predict the answer with a ratio. That's genuinely the full toolkit. If Clarix made this click, follow along. We're doing the entire syllabus, chapter by chapter. See you in the next one.